Welcome to part 2 of my Etch-a-Sketch video where we're going to start the drawing mode. So we've got an array, and arrays are 0 indexed, meaning that the first row is row 0 and the 8th row is row 7. And we relate the top row of the dot matrix display, which is wired to pin 2 of the Arduino, to the first row of the array called row 0. And this is used when the analog read pot value returns 2 from the highest voltage. The lowest analog read voltage returns 9 as the Arduino pin 9 is wired to the bottom row of the dot matrix. Here we reference the 8th array row called row 7. This column analog read returns 10 for the lowest voltage as the Arduino pin 10 is wired to the left column of the dot matrix, and here we reference the first array column called column 0. And the column analog read returns 17 for the highest voltage as the Arduino pin 17 is wired to the right column of the dot matrix, and here we reference the last array column called column 7. So we've got position mode where a single LED is lit to find where you are when you're drawing and it has no memory, and then display mode, adjacent LEDs stay lit via the display array memory, and you can switch between them with the mode switch. So just to show you an example from the pot values, here we've got the row equals 9 and col equals 10, and this relates to the display array position 7, 0. We're going to write a 1 to that if we want to light up this LED. Then when row is 2 and the col integer is 10, that's referenced by the display array element 0, 0. Now we've got 0, 7, and finally for the bottom right, row is 9, col 17, and that's display element 7, 7, which needs to be 1 to light the LED up. So if you want to draw this square, you can just look here at how the row and col integers change from the analog reads and how that changes the array values. So we'll write the rows low, then we'll write either a 1 or 0 to the column depending on whether we want the LED lit up or not. So for example, the top right LED, the row integer is 2 and the col integer is 17, and this relates to the element position of 0, 7, and you may notice that the row in the display array is the row integer take away 2, and similarly the column element position is the column pin 17 take away 10, and this will be handy in our coding. So first of all, we'll do the mode selection by flicking the switch on and off. We need int mode 1, because that's int mode equals 1 rather, that's pin 1 of the Arduino, and a value to store its value. Then we'll declare it as an input, and then after we've read the row pot and the column pot and assigned row and col integers, then we put the following code. So we read the mode switch. Mode val is digital read of mode, as in pin 1, and if it's 0, then we're in position mode, which ignores the array, and we use the code from video part 1. That's the position mode code that you use to find out where you are if you're lost on your display. If the mode value from the binary switch is 1, then we go into display or drawing mode, and this updates the array. That's the fun part. So to write to the array, to set the 1s in it, we use the following code, as in draw mode or display mode. Display row minus 2, which is the row, col minus 10, which is the column, equals 1. And then to output the values from the array, we do the following. For integer r equals 2 up to 9, so this is a for loop. I've called it r just for row. We're going to digital write the row low. That enables the row. And then once we're in one of the rows, we do another for loop inside that for c equals 10 up to c equals 17. And then we digital write between pins 10 and 17 the value that's in the array at that position. Then we disable the column by writing C low. And then outside of the C for loop, we disable the row. And then it'll cycle through each row and then through each column. So there's our integer for the mode, which is pin 1, our binary switch. Then we just do pin mode for that, even though we did it in part 1. We've got mode value, on or off. And here we declare our 8x8 matrix or array of arrays. So mode value is digital read of mode. And if the switch is switched off, the mode value will be low. So we do our position mode code that we did in video part 1. Otherwise, as in else, our little switch has been set to 5 volts, so it'll be high. So in this else part, we're in drawing mode, where we're going to actually draw on the dot matrix. So as we said before, display row -2, column -10 equals 1, which will update all the time. And for loop for R is 2 up to 9, we'll write the row low. So we're writing pins 2 to pins 9 low to enable them in order. But in between that, we write the value of the array to the column, which will make an LED either on or off, depending on what the array says it is. We can have a delay, or we can decide that later if we need one. Then we're going to write the column pin low, come out of that little for loop for the columns, and then we're going to write the row high to disable the row before we go on to the next row. Maybe a delay, we might not need one. And there we are. What I'm going to do at this point, we cannot use the word display, it's kind of reserved. So I'm going to change my display name of the array to DISP or DISP. And I change that everywhere in the code and we'll be fine. And it's a good idea to trim the ranges so there are gaps in the analog read, because analog reads jump all over the place. We may have 2 LEDs looking like they're on, which is no good. So we trim the ranges down so there's gaps. And that means there's no sort of jitter in our analog reads. So the col and row values will be nice and stable. And there we go. You may want to have a look at my RGB. We've got 8 different colours we can use on this, and get it made. And thanks so much for watching, and I hope you enjoyed it. All the best for now.